Okay, we were looking at what happens if you don't have a right triangle. In the last section we looked at the law of sines, but to use the law of sines you have to have an angle and its opposite side, right? You have to have a pair. What happens if you don't have an angle and its opposite side pair? Then you use the law of cosines, which says you can take any side squared as the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the angle between them. Notice this angle here will always be opposite of this first side. This angle here will always be opposite of this side. Don't memorize three versions of the same idea. Any side squared of a triangle will be the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle between them. So that's the way to think of it. So in terms of the cases, we looked at the first two last time. You would use the law of sines when you know an angle and its opposite side. If you know two angles of a triangle, you know the third. So you'd have an angle and its opposite side, law of sines. Here, side angle, you have an angle and its opposite side, you'd use the law of sines. But remember, this is the ambiguous case. If you're given an angle and two sides, but with a pair, you get three possibilities, right? You'd have two triangles, one triangle, or no triangles. Today we're going to look at this. What happens if you have two sides and an included angle? Notice you do not have a pair. You do not have an angle and its opposite side pair. So you'd have to use the law of cosines here, and then certainly if you have three sides and no angles, you don't have a pair of an angle and its opposite side. Use the law of cosines here also. The good news is the only time you're going to have more than one possible triangle is in this one, the ambiguous case. These other three, there's only going to be one triangle possible. Alright, so here we go. Suppose we have angle A is 20 degrees, B is 8, and C is 4. So the picture looks kind of like this. Notice you don't have the side opposite this. What you have is the included angle between these two sides. So use the law of cosines. You'd say a squared equals 8 squared plus 4 squared plus 2a times 4 cosine 20. When you solve for a, make sure you're in the degree mode. You get a is 4.5. We're not done. But now that you find a is 4.5, now you could use the law of sines to find, say, one of these angles. You could say sine of 20 over 4.5 is equal to the sine of c over 4. There's only one possible triangle. Since the side is so short opposite c, you know that this has to be an acute angle. So you're going to use the one in the first quadrant. When you take the inverse sine, you get 17.7 degrees. And then B would be 180 minus the first two, so B is 142.3. Alright, what happens if you know three sides of a triangle but no angles? So the picture looks like this. Looks like we're going to have an obtuse angle here and two acute angles here, right? Well, you can use any of the three versions of law of cosines. Let's use this one. You plug in everything and you're going to solve for cosine C. Now look, this is going to be, because this is 10, the longest side, this is going to be the biggest angle. It's going to be more than 90 degrees, isn't it? The cosine of an angle that's more than 90 degrees is negative. So when you solve this for cosine C, you're going to get a negative number. Cosine of C is negative 0.3125. So this thing right here is negative 0.3125. When you take the inverse cosine, it takes care of it for you. You don't have to worry about cases, because remember, the cosine is negative in the second, positive in the first, so you don't have to break it up and consider two cases with this law of cosines, like you did with law of sines. C is 108 degrees, 108.2, so then the way you can find angle A is you could use the law of sines. You know angle A is an acute angle, so you could say sine A over 8 is sine 108.2 over 10. Cross multiply, solve for A, take the inverse sine, and when you take the inverse sine you get 49.5, and then B would be the 180 minus the sum of the first two. That's how it works. Alright, let's look at this one. Okay, well this triangle has angle B 25 degrees, A is 16, and B is 8. How would you do this? How would you solve this triangle? Well, it turns out you wouldn't use law of cosines because you actually have a pair. You have an angle and its opposite side pair, so you use the law of sines here. This unfortunately is the ambiguous case. So tell you what I'm going to do. I'll let you do this one on your own and we'll go over it, okay? Hit the pause button and see if you can solve this triangle. Make sure when you go from the inverse sine of an angle to the angle that you look at two different cases. Okay, so I went like this. Sine of 25 over 8 is the sine of a over 16. So you get this, right? And when you go from here to here, there's going to be two possibilities. One is 57. When you take the inverse sine of 2 times sine 25 degrees, you get 57. Your calculator gives you 57.7. But when you take 180 minus this, you get 122.3. And is that possible? Unfortunately, yes, it is possible. So you have two cases. So then what you should have done is just consider two cases. For the first case, if A is 57.7, you would then note that if you subtract 180 minus 25 plus 57.7, you get the angle C is 97.3. And then all you have to do now is find little c, right? If you use the law of sines, you can find that little c is 18.8. But don't forget about case B. Case B is that angle A is 122.3 over here, see? And that's a possibility as well. What you would then do is if angle A is 122.3, you would then, angle C would be 180 minus the sum of the first two, minus 25 plus 122.3 is 32.7. Then you could find little c2 by using the law of sines, and you end up with little c2 is 10.2. A lot of work, huh? Okay, let's do a couple more. Okay, let's do a couple more here. Would you use law of sines or law of cosines here? Notice you have an angle, and this angle is between these two sides, so you use law of cosines. The picture looks kind of like this. So you could say c squared equals 8 squared plus 4 squared minus 2 times 8 times 4 times the cosine of 50. And when you take the square root, remember we're always talking about positive distances here, I get c is about 6.2. Now that you know an angle and its opposite side, you can find the other two angles. Now, this is important. One of these angles is going to be an acute angle. I know that B is an acute angle because the opposite side is 4. It's so short. So I'm going to find that one first, because that way when I use the inverse sign, I know I'm on the first quadrant on there. A looks like it's probably going to be an obtuse angle, but let's use law of sines to find angle B. Sine of B over 4 equals sine of 50 over 6.2. So when I find angle B using the inverse sine of 4 sine of 50 over 6.2, I get the first quadrant, right? 29.6. And then the last angle, angle A, would be 180 minus the sum of the first two. I get 100.4 degrees. Okay, let's do an application problem. Two boats leaving port at the same time. The first boat travels 20 miles per hour at this heading. This is called 64 degrees east of north, okay? 20 miles per hour. The second boat travels 10 miles per hour, and this heading would be called 40 degrees east of north. Find the distance between the boats after 2 hours. So the picture looks kind of like this. This first boat, A, it's 64 degrees east of north, so you drop down 64 degrees east of north. That's this first boat. Second boat is only 40 degrees east of north, so you drop down 40 degrees. Now in 2 hours, though, boat A, if you multiply rate times time, you get distance. Boat A has gone 40 miles, boat B has only gone 20. So this is a classic law of cosines, isn't it? Where you have the angle that's between them, though. Can you figure that out, what the angle is? If you subtract 64 minus 40, you get 24. So this is 24 degrees, and you know these two sides, you can find the distance that's between them. That's the length of this side. So d squared equals 20 squared plus 40 squared minus 2 times 20, 40, cosine 24. Take the square root, you get 23.2 miles. That's it. Alright, we'll see you next time. Bye-bye.